Hey guys, so if we have 1 to the 4 over 1 plus 1 to the 4 over 2 plus 1 to the 4 over 3 plus 1 to the 4 over 4 plus 1 to the 4 over 5 and keep doing that, it's equal to 1/3 exactly. Another way we can view this is 1/4 plus 1/16 plus 1/64 and so on. You just do powers of 4 in the denominator. We can visualize it geometrically if we take a square, cut the square into 4 equal parts, and then we have 1/4 of it's right here. So if we color that red, 1/4 of the square is red. If we color these gray, you can see that 1/3 of everything that's been colored is red. And then if we cut this into fourths, each of these is 1/16 of the entire square. So if we color this guy red, it'll be 1/16 of the whole square. And if we color both of these gray, we still have 1/3 of all the shaded stuff is red. And we can repeat the pattern again, do fourths down here, and each of these is 1/64 of the entire square. So if we color this guy right here red, this is going to be 1/64 of the entire square. That's going to represent this piece right here. And then we make these gray. You can tell 1/3 of everything colored here is red. So that means 1/3 of everything colored so far is red. We can keep repeating and do smaller and smaller bits, and it's always going to keep being 1/3 of everything that's colored is red. That will continue indefinitely, and we end up having 1/3 of the whole thing is red. This is cool geometrically. I'm actually convinced by this, so let's put a box around it. But we can also do it with algebra. So we take our original series, it goes on forever. We set that equal to n. If we multiply both sides of the equation by 4, we'll get 4n on this side, and on this side, each of these numerators will have a 4. Then we can bring down the 4n. 4 over 4 is equal to 1. 4 over 4 squared, well, that's going to cancel one of them, so this will just be 1/4. And then 4 over 4 cubed, well, that'll be 1 over 4 squared. 4 over 4 to the 4, that'll be 1 over 4 cubed, and that pattern is going to continue forever. So this stuff in the parentheses is the same thing as our original series. Both of these are the same, so we can plug in n for this right here. And then we can bring down the rest of this stuff. So we have 4n equals 1 plus n. If we subtract n from both sides, 4n minus n is 3n, and then 1 plus n minus n just gives us a 1 on this other side. And then we can divide both sides by 3, and that gives us n equals 1/3. So our original series right here, which we set equal to n, is 1/3. How exciting.